Hello everyone, this is Weierstrass factorization theorem. In complex analysis statement, there exists an entire function with arbitrary zeros Zn provided that in case of infinitely many zeros Zn tends to infinite as n tends to infinite, and every entire function with these zeros can be written in the form fz is equal to zm egz power of, and this is expansion form where the product is taken over all zn does not equal to 0. The mn are certain integers and gz is an entire function. Proof: we shall determine an entire function with a finite number of zeros. Let us suppose fz has m zeros at the origin, and let the other zeros be denoted by z1, z2, z3. We have fz is equal to zm 1 minus z upon z1, 1 minus z upon z2, and so on 1 minus z upon zn into hz, where hz is an entire function with no zeros. Hence hz can be written as e power of gz, where gz is also entire function. Since fz is equal to zm egz and this, if there are infinitely many zeros z1, z2 and so on zn with zn does not equal to 0, limit n tends to infinite, zn tends to infinite, and if a zeros whose order m at the origin, then fz is equal to z of m e of gz and this. Now we shall prove the existence of polynomial p and z such that summation this equation second, the entire function will be converges if the series u and z is equal to log this, converges by Taylor's series, and this. This is expansion of Taylor's theorem, so we can write u and z is equal to 1 upon mn plus 1 z upon zn power of mn plus 1 plus this equal to 1 upon mn plus 1 z upon zn mod of power of mn plus 1 into 1 upon 1 minus z upon zn. This equation third. Now the suppose the series this convergent, this equation fourth, and using equation third u and z tends to 0 as n tends to infinite. Thus the imaginary part of u and z lies between minus pi to pi. Also the series converges absolutely and uniformly for z is less than r by m test, and whose product represents an analytic function. Now taking mn is equal to n, then zn mod tends to infinite and r upon zn mod is less than 1 upon 2 hold, and this converges series in the whole plane. If z is equal to 0, then the infinite product this defined by an entire function whose zeros are 0, z1, z2, z3 and so on. If fz is an arbitrary entire function with prescribed zeros, then the quotient is this is an entire function without zeros, or fz is equal to this equation fifth. Hence proved.